Okay. Lesson 3, graphs of linear functions and rate change. All right. Functions on the left and 2 on the right have tables shown below. Find the rate of change for each function. In other words, a change in y over the change in x. Examine each of them, make a conjecture about which will be linear, and justify your claim. So, in other words, first of all, the first one, in other words, rise over run. Okay. So for the first one, we've got here going from the first one here, we have a +2, then we have a +1, and then we have a +3. Here we have +2, +1, and +3. So rise over run, we have 2 over 2, which equals 1, 1 over 1, which equals 1, and 3 over 3, which equals 1. Here, for rise over run, I have a +4, I have a +5, and I have a +3. Here I have a +1, +1, and a +1. So I have a 4 over 1, which is 4, a 5 over 1, which is 5, and 3 over 1, which is 3. So the table on the left is a function. And it would be linear because it has a constant rate of change. Table on the right does not. Okay. So also, if I check the slope for each of these, I can figure that out as well by showing the work. If I showed the work here to find the slope for each of these, and I did the work based on that, my slope is y2 minus y1, or 2, 5, and 4, 7. y2, y1, x2, x1. So let me move this m down here just a little bit. And I had 7 minus 5 over 4 minus 2. I have 2 over 2, which equals 1. Then I also have 4, 7, and 5, 8. And for that one, I have x1, y1, x2, y2. And for that one, I have 8 minus 7 over 5 minus 4. And again, here I've got 1 over 1, which equals 1. Then I have 5, 8, and 8, 11. Okay. And once again, they all equal 1. So I'm proving that here. On this side, I have 0, 3, 1, 1. So x1, y1, x2, y2. So m equals 1 minus 3, 1 minus 0. I have negative 2 over 1, which is negative 2. So, oh, sorry, this is negative 3. I apologize. Let me redo that. So leave change here. I get 4 over 1, which is 4. So then I have 1, 1 and 2, 6. So I have m equals y2, x2, y1, x1. So I have 6 minus 1 over 2 minus 1. So I have 5 over 1, which equals 5. Okay. And therefore, these are not the same. Therefore, nonlinear and not a function. Okay. So now, if I go to my first example here, okay, it says, let's further examine function 1, which assigns the inputs and corresponding outputs shown in the table. Why is function 1 a linear function? Check at least 3 pairs of inputs and their corresponding outputs. Well, okay, so I am going to check 2, 5 and 4, 7. Okay, so x1, y1, x2, y2. So for this situation, I have m equals 7 minus 5 over 4 minus 2. Well, that equals 2 over 2, and that equals 1. So my next one, and it says check at least 3 pairs. So I'm going to check 4, 7 and 5, 8. Okay. So y2, x2, y1, x1. So here I'm going to have m equals 8 minus 7 and 5 minus 4. So here I get 1 over 1, and that equals 1. The last pair I'm going to check is I'm going to check 8, 11 and 2, 5. Because on the other ones, we already checked these ones. So I'm going to check it differently just so that you can see what differences there would be. Okay. So here I'm going to check x2, y2, x1, y1. So m equals 11 minus 5 over 8 minus 2. So here I've got 6 over 6, and that also equals 1. So now it says, what equation describes the function? And remember, here's how we do that. Well, we know our slope is 1. So in other words, what we have to do is we have to find, okay, the y-intercept. Okay. So here we know that our slope is 1. So here we are going to take a point. In this case, I'm going to take 2 and 5. And I'm going to substitute them in. So I'm going to replace my slope because my slope is 1. So I'm going to say my y is 5, my slope is 1, and replace my x. And I am going to solve for my y-intercept. So here I've got 2, so 5 equals 2 plus b. Subtract 2 from both sides. So my b equals 3. So my equation then would be y equals 1x plus 3, or y equals x plus 3. It says, what will the graph of the function look like? And explain. Well, it would look like a line, because there is a constant. Oop, if I can spell constant. Trying to write too fast. Rate of change. So next is example 2. So the following table represents the outputs. Let me fix the light, guys. Says the following table represents the outputs that a function would assign to given inputs. Oh, I'm sorry. There we go. We want to know if the function is a linear function, and if so, what linear equation describes the function. Okay. Well, we have to find out, first of all, if it is a function. So I'm going to take the points. Okay, and we've got to figure out if it is a function or not. So we're going to take -2, 4, and 3, 9. And let's find our slope. So x1, y1, x2, y2. And here we have 9 minus 4 over 3 minus -2. So we have 5 over 5, which equals 1. And now let's try 3, 9, and I'm going to try 5 and 25. So I have y2, x2, y1, x1. So here I've got m equals 25 minus 9 over 5 minus 3, which is 16 over 2, which equals 8. So in this case, the rate of change is not, it says, what do you notice about the rate of change? Okay, the rate of change is not constant. Okay, so now it says, if this were a linear function, what would we expect to see? There should be a constant rate of change. If this was a linear function. we have enough evidence to conclude that this function is nonlinear, would the graph of this function be a line? And explain. The graph would not make a line because there is not a constant rate of change. In other words, you cannot write ny equals mx plus b form. And this ends our lesson.